Art takes so much time. It takes so much work. I've been on my artistic journey now for 20 years. In some of those years, I made great strides, and in other years, my progress slowed to a trickle. Some years I gave up on it completely. But you know what? Every year, you just try and get a little bit better. There's a great line from the movie Life is a House, where one of the characters says, "Change can be so constant that you don't even feel the difference until there is one. It can be so slow that you don't even notice that your life is better or worse until it is. Or it can just blow you away and make you something different in an instant." That's definitely happened for me. One of the most fun things about being an artist is watching yourself get better, looking at your old work, having this record of time through your work and seeing yourself and how you evolved and what you were thinking. In today's video, I'm going to show you my latest personal project, which I'm calling the Cybernetic SMG. It's based on concept art by Yin-Tian Jay, one of my favorite concept artists in the business. I think he does really refreshing, unique concepts, just really interesting stuff. But his stuff is complex, pretty heavy. He's an incredible draftsman. He does a lot of photo bashing, and I'll even talk about how I broke down his concept art. But I just really love his work, and I'm inspired to do it, and it's challenging. It's honestly challenging to convert to 3D. Last summer, I embarked on a mission to learn Fusion 360, which is a CAD modeling program. And I've always wanted to learn Fusion 360, but it was always kind of daunting and I never really found the right project for it. One of the key benefits of Fusion 360 is that it's parametric modeling, which is to say you can draft the shape, extrude that into a 3D object, but then you can always go back in time and manipulate that object further. So it's very flexible. You can go back in the past, modify something to affect the future. It's non-destructive. So today's video is not intended to be a tutorial in the traditional sense. Like, I'm not going to tell you like every button to click to get this result. Really, it's just going to be a project story. I'm going to tell you what I was thinking, some of the struggles I faced, and also I will provide a couple tips, a couple things. You ideally want to start with some kind of schematic, some kind of 2D drawing to help you trace. Overall, the design itself is relatively simple, and I thought that was the appropriate skill level for me, having just come into Fusion 360. But the concept doesn't tell you everything, and this is one of the fun parts about being a 3D modeler, is that you get to kind of fill in the gaps of the things that are not there. I had to go and do some digging into what these things were that I'm looking at, because obviously like I can tell that it's photo bashed, but there are some elements there that are very clearly unique. The concept itself is not a typical gun. Like, I don't really know much about guns, but even I know that the stuff at the top, the attachments that usually have that the Picatinny rail that you add attachments on, is not present in this drawing. And I partly assumed that was because it was kind of more of a sci-fi concept. For example, even like screws, I wasn't going to put screws on this gun because they almost feel a little bit too contemporary. And I didn't want to place the gun in a specific time. Another thing that struck me as unusual is it's got this little battery box in front of the sight. So that kind of renders the sight completely useless. And quite clearly, this gun has a bunch of different materials. Like, I don't think there's one unified metal across the entire thing, or polymer. Even though I have this concept, I still needed to find more references that I could then draw on for more detail or form. So I had to figure out what these components actually were, or find something similar. I was actually quite successful in finding the exact references that were used in this image. For example, in one of my gamer discords, somebody just linked this gun review channel called Forgotten Weapons. And what do I see on the homepage but the exact weapon that I was looking for? H&K G11, German made. Looks like it's something straight out of Starship Troopers or RoboCop. It has an extremely unique look. So, right away I was like, oh my god, it's the gun that was used in the concept. And one of the coolest parts I learned about this is that in fact the details that are on the gun are inverted in the concept. It was flipped. So it was incredible to find a reference, this exact reference, to get a sense of the materials, the scratches, the textures. The piece that I put the most effort trying to find was actually the sight. I could not find a gun sight that looked like this concept. It wasn't until I had the idea to flip the concept art and a word revealed itself, and it said Ikegami. And so I look up Ikegami, and what do I see but a whole bunch of old kind of 90s camera gear. And through this, not only do I find the sight, I also find the battery, and I realize that both of those components are from a camera. And so I was shocked to find the exact reference that was used, the very photograph that was used for this concept art. And I personally love this style of technology. It looks a little dated by today's standards. This is probably like 80s or 90s, but I love this kind of old Japanese technology stuff. It has such a unique forms and structures. It's not too modern. We haven't entered the period of Apple design where things are like no buttons allowed or shapes or shadows or anything like that. Much more complex than what we see nowadays, but something beautiful about this work, and usually in dark colors or black. It looks so good. So I absolutely love this era of technology. Finally, it was time to actually start making the model in Fusion 360. Fusion 360 made modeling fun. Like, it was just pure fun because you're not worrying about all the technical stuff. You're really just thinking about how do I make this look like what I want it to look like. And for a little while there, it actually revived my interest in 3D, period. The parametric workflow is so forgiving. Like, you can put a little hole for like a screw in a gun and then decide, I actually want to move it over here. And it just updates dynamically. Like, it's so beautiful. Like, you don't have to worry about polygons or anything. So I can see why this is used for weapons and game design, because it is so forgiving, a lot of flexibility, and you can make modifications quite easily. The hard part about CAD is when you have to convert this to polygons, and that's a whole other part we're going to get to. CAD to polygons for games is not the easiest thing, to the point where I'm not even sure I can say that I would do everything in Fusion 360 down the road. I do think that the typical standard polygon modeling or ZBrush modeling is still ultimately faster, but it's just nice to have Fusion 360 in your pocket because it's excellent at other things. So yeah, I was deep into Fusion 360 for a while. I even picked up a 3D mouse because I wanted to see if it would improve productivity or make it easier to work with. Ultimately, no, it's not. I think a mouse and keyboard is easier to use. However, it does allow you to do this sick thing where you can fly around the model in all directions at the same time. So that part's really cool. I think it's really cool for videos or demonstration purposes, but for actually working with, I prefer to have the full range of keybinds by just using a keyboard. So hopefully you can kind of appreciate that, like, bevels, easy. Patterns, easy. Booleans, easy. My personal favorite feature are the pattern tools, which allow you to repeat an extrusion or a Boolean, just as I'm doing on this inner tube. And this would be a perfect example of something that would be so messy to do with polygons. Like, you can do it with Booleans and everything, but it's just messy. The only critique I would have in CAD is it is a little harder to work in multiple dimensions at the same time. CAD would much rather work orthographically, so looking straight on front or side or top view or bottom view, but it's not great at crossing those dimensions at the same time. So for example, if you had a diagonal piece that also happened to curve in space perpendicularly. And so ZBrush is actually like the perfect counter to that problem. But there's really not much else to say. I mean, like, honestly, anybody can pick this up and start the 3D model. You don't need to know anything about 3D. You don't really need to know anything about polygons or topology. It just doesn't matter in this CAD environment. I did experiment with removing some of the detail from the high poly version of the CAD model so that I could bake those details in instead. However, the bake just didn't look as good as having it modeled into the geometry, especially when you see it at an angle. There's a perspective shift that a normal map simply can't accomplish. 360 does have tools to export the model to FBX or OBJ directly to get it into mesh, but Moi 3D is still, in my opinion, a better tool because you can get way more control over the poly count. So Moi 3D is another CAD modeling program. I picked this up years ago, back in the day when I was experimenting with CAD. The other one that people are using today is called Plasticity, but I have Moi 3D, so I use that to convert the CAD model to polygons. And it's great because you can play with the level of detail, the poly count directly in this. Now, I wouldn't use the model that it spits out directly from Moi. I think it's too high poly or too low poly. You need to kind of find an in-between. When you convert a CAD model into regular polygon geometry out of Moi, you have a few export options, one of them being Ngons, and Ngons is a lot cleaner. It converts, though, all these fillets into patches, so typically if you were choosing curves, this would be kind of like how curves work. Obviously you can see this doesn't work here, right? This produces a whole bunch of Ngons that I am cleaning up, and is part of the only reason why this friggin' retopology is taking forever. But I'm just going to show you my technique for how I clean this up. So obviously first you just want to select the problem area. And I want to extract these faces, and you could just use the shift right click extract faces, Maya's default. However, if you notice when you use the extract tool in Maya, it creates a bunch of groups and also an empty transform node, and it just makes everything messy, and I don't want that. Instead, I'm going to use Malcolm 341 Megapack scripts. It's got one in here called extract, and if you click it right here, As you can see, it creates no subgroups and it keeps the outliner nice and clean. And I just really like this bunch of scripts here. So I just simply am extracting these faces. The next thing I'm just going to do is delete these unnecessary verts because we just don't need these, and this is what's creating the n-gons. Okay, nice and clean. And next we're just going to delete these unnecessary edges that don't go anywhere. And by doing that, we're now able to insert edge loops, hopefully across each side, okay? But by holding shift as you use insert edge loop, it's gonna preserve some of that curvature. That's called edge flow. It's adding a little bit of edge flow to each one. And then we're also gonna do along the X side. And it doesn't have to be perfect, just try and get it as close as you can. Okay, something like that. And next, we're gonna delete the unnecessary edges. So we don't need this one anymore. We don't need this one. So we're just gonna remove these. And we're also gonna remove these ones here. Okay, so that's looking a lot better. Next, we're just gonna make sure we select all the unnecessary verts on the main part of the geo, except we're gonna deselect the faces that will actually delete the structure. So we'll just delete that. And then we're gonna make sure that the new patch that we've created snaps to the main body. I like to work the small to big or attach the small to the big because the primary shape is more important, except for this little part here where we have a shortage of verts. We're gonna have to add a couple more. So I'm just gonna add a vert there, and everything should fit perfectly together. Okay, so that's how you create a patch. Now real quick, obviously we can't leave this interface to be a massive n-gon shape, so I'll just show you how I like to cap these points. I like to drop a line straight down to the bottom corner. You can also hold Control Shift to do a 90-degree cut. So right here, I'm gonna hold Control Shift to do a 90-degree cut. Something like that. And now you could manually add, triangulate this little corner here, but a better way to do it, a faster way to do it, is to use the edit mesh or mesh triangulate script right here. I have it added to my bar, but obviously that didn't quite work. What you can do instead is just give it a little bit of a guide. I like to split it down the middle and now try hitting it with triangulate. As you can see, that's a lot faster than manually trying to add triangles to that. And that's how I like to cap those corners. Okay, so that's it. Now I've done this, like this example, like honestly, it feels like 100 times. I had to do it for like all of these areas. Absolutely terrible. But again, it was part of the learning experience for working with CAD and patches out of Moy 3D using n-gons. So for example, here's a model, for example, that is pure n-gons out of Moy. The curves are nice, but like notice how nothing is aligning right now. So that is the cleanup work that I'm doing right now. Like this piece is going to take me a little bit of time to get that, but I will say it does preserve and protect the actual curvature as it looked inside of CAD. So even though it's a lot of work, if you do it, it does come up with a nice result. By the way, also, like I'm working with a lot higher polygon than I think is normal for a video game mesh. I'm probably working like basically like a whole 1 or 2 subdivs higher than a typical video game mesh, but I want that. Like there's no video game that this is models for. This is just meant to look good without being sub D. And so I'm just using all the polygons that I actually need. And then in some areas, for example, like some small detail like here, I don't need it to be super high poly. If you turn off the wireframe, you can kind of see like you're not really going to notice that until you get in like that. So yeah, I just want the edges to look really smooth from like a medium distance, almost as if it was a sub D, but not quite. From there, once the whole model was retopologized and beautiful and reduced poly count, quote unquote, I had to do the UVs. And the UVs are absolutely critical to the quality of the model. People always complain about UVs. I think maybe they complain about like how long it takes. I personally find retopology much worse, but I love UVs. I think UVs are absolutely critical. It's the first time that your model communicates with textures, and how you arrange it greatly impacts your texture quality, because the UVs also determine your materials and your UDIMs and all that stuff. It's the literal foundation of how you're going to apply materials to your model. And so the better job you do at it, the better the model's going to look. So guys, my model's pretty much done. As you can see, I've converted to the full gold, which means I have everything UV'd finally. The only thing that hasn't happened yet is I haven't like fully laid it out, like all the pieces. And this is where texel density and texture resolution really comes into play. So I'm going to do a test here just to figure out what exactly I'm going to do here. In case you didn't know, so like you have your model, but then you also have UVs, but these UVs actually have a resolution, and we call this texel density. The higher the texel density, the more detailed you're going to be able to get with your textures, like scratches and dust and all kinds of cool stuff. So inside of Maya, there's this cool little feature right here, texel density, under the UV toolkit. And currently, assuming that I'm going to use a size of 4K for my texture maps, the texel density is set to 15. So let's go over to Substance Painter. And the first thing I want to do is I just want to take a look at the normal maps. Use low poly mesh as high poly. I'm going to set it to 4K. I want all of this stuff, normal, world space, ambient occlusion, all that stuff, because really I just want to get a sense of how my UVs are working. So I'm just going to bake these out real quick in 4K. Okay, so once that's done, now I'm going to look at it in the map views and let's see how it's looking. Okay. So remember, this is 4K, so like this kind of messiness I'm not liking, right? So, and like, see how there's like pixelation going here? That means that my UVs are not clean enough to support this. It looks kind of dirty. Like, considering it's 4K, this is not the quality I'm looking for. Because if I want like fine scratches and dust and details, then this is not looking so good. So I'm seeing already that like I need to make some adjustments. Like, ooh, that's really ugly, right? Ideally, you want the UV to be straight because, again, ultimately these become 2D pixel images, and pixels are made up of like little squares. And so a diagonal can only be resolved with squares ultimately. So that's why, for example, right here, it's very jagged. It's because this piece is on a diagonal. So if we look at Maya, so if we look at this diagonal, it's on a diagonal, right? So this diagonal would have to be divided into little pixels that are on a grid. So the way to cure that would be to cut this piece out separately. Let's unfold that and rotate it to be straight. All right, let's take out this bottom piece. Okay, that's a little bit better. Okay, that's straight. So now it'll be aligned straight. If I wanted it to be even cleaner, I could just split these off completely, just cut them into their own little pieces. And I'll just send this back out and we can see right away like the difference that this one little change will make. What else is jagged? Let's see. So I'm not liking these circular things on the side, these little circular details. Again, I could have just baked these into the normal map. Like I didn't actually have to model this with geometry in the low poly in game, but I felt like it. So I'm seeing some like, I don't like this here at all. This looks bad on the edge here. And also I'm kind of feeling like there's some blurring here. Maybe I just actually need, I need to hit this with an unfold. Oh yeah, I think that needs to be unfolded. Oh yeah, see the difference? So like look how wide this is now. This is how it was before. So it was squashing it. It was getting not enough texture resolution in that spot. Again, you want to avoid the diagonals. So like for example, I could cut this here. So I straighten that so that's straight. Oh, this was another one that was really bothering me. So like let's see, like look at all this messiness here. Let's see if we can do something about that. So that is the top. There's too much, yeah, there's too much information. There's like too much in and out going on here. Let's cut this out. See, already that looks like it's straightened out a little bit. Same thing for the top. Let's cut that out. And the sides we can just break it and everyone will be much happier. And then there was also this part here, like why is this so like jagged like on that thing right there? Let's take a look at the UV. So again, it's being like the top face of this thing is merging with the side. It's like a 90-degree change of plane. Let's chop this off. Let's chop that off, and then we can give this its proper shape. Yeah, that looks much better already. The general rule is you want to create a UV seam on every 90-degree corner for clean bakes. These plane changes need UV seams and should be set as hard edge. So let's take a look at the world again, and look how clean that is. Like that is so much cleaner. If we compare it to the original, so this is what it used to look like. So again, this is with the UVs, the shells being on a diagonal. As you can see, because it's a pixel grid, it can't resolve diagonals, as well as if you were to just align the UVs to be straight with the pixel grid, the direction of the pixel grid. Look, so much cleaner. That's looking better. Let's take a look at our top side. So much better. Look at that. Beautiful. All right, so yeah, so that's why I do this. But as you can see, it just makes for a much cleaner result. If you're going for like, I mean, in this case, I am trying to go for like higher quality than I normally go for this kind of detailed stuff. This is looking so much better. These are like the necessary minute things that really can make a difference in the overall quality of the model. Finally, once the model and the UVs had been finished, it's time for texturing in Substance Painter. And this is the fun part. This is when you can start to bring this boring gray model to life. As I'm texturing this gun, I'm trying to find the balance between being grungy and dirty, but also not too grungy and dirty. You do have to have a little bit of restraint because it's really easy to just slap on scratches and dirt and everything everywhere and call it done. But you also have to put things where it would make sense to put things, you know, like you're not gonna get these intense metal scratches as if somebody like hit it with a sword in like little crevices of the model. It's just not gonna happen. So typically I like to push it further than I actually want to go, and then I go back and I reduce some of that. But in CG, I think you need to go a bit overboard to really sell it, the detail. The computer's always trying to take away detail and make things look a little more technical, less organic. And so I think by pushing the detail, it's better to go further and then reduce than to not go far enough. And in the end, the result for my weapon is kind of like a stylized reality. About halfway through the texturing process, I simultaneously was starting to set up the asset inside of Marmoset. It's good practice to have a preview of what your asset is going to look like in the final render engine. Now that I'm happy with the textures and materials inside of Substance, it's time to go to Marmoset for real. Unfortunately, Marmoset doesn't support UDIMs yet, so that kind of sucks, but there is a workaround where you just manually create one new material per UDIM. From there, the textures did look a little bit different than Substance, as I predicted, and so you have to adjust the intensity of the different values, the transparency, to get it looking what you want. It's not going to look exactly like Substance, but it'll be something else. There's honestly such a joy when you see your asset rendered for the first time, because you're working in this gray and pale environment for so long, like 80% of the asset, and then finally you get light and raycast shadows and stuff. Oh my god, it just, everything pops, everything comes together, and you're like, wow, okay, wait, this is what I was trying to make, I forgot. And so if you do your job right in the model, and the topology, and the UVs, and the textures, and the materials, and the balancing and everything, it should come together pretty successfully every time. I also think when you add light, it really establishes the significance of things. Like some things that you thought were important when everything was evenly lit are not actually as important because they fall away into shadow, just the way that the self-cast shadows happen. Sometimes things are not as important as you think, and some areas that you thought weren't important are important. They're highlighted. And so again, it's just good practice to have an early preview of how all this stuff works together so that you can work towards it knowing what the end result will be before being completely surprised at the end. So at this point, it's just pure fun and creativity. You know, you're just trying to get the result you want, playing with different lighting, playing with different backgrounds and angles. In this case, you can also play with the depth of field and the field of view and the blur, everything, chromatic aberration, and the film grain or digital grain. Overall, I found this to be a very successful project. I was really happy with the results. Some of these beauty shots look absolutely sick in my opinion. And I also learned a lot. You know, I've been stuck in a kind of stylized animation phase for the last few years because I was working on a production where that's the kind of stuff we were doing. Hand drawn and hand painted textures. And so I lost sight of detail and realism, but I definitely feel like I'm focused on that now. And so my next few works are probably all gonna be in this style. Thanks for watching, guys. I know this was a long one, but I actually had to cut it down way more than I wanted to just to fit within a reasonable time frame. Hopefully you got a sense of how I made the weapon. At the start of the video, I mentioned artistic growth. And I look at stuff like this weapon and I could not have done this a few years ago. A big part of that is obviously the tools and the software and also the availability of training. You know, like YouTube is such an incredible resource. So whatever you're up to, guys, I hope you're killing it. I know there's a lot facing artists nowadays, especially with AI, and I'll talk about AI in the future. And also the fact that we're in this climate where it's never been a more uncertain time for artists. It really hasn't. So here's to all the artists, guys, for 2024. Mad respect to all you guys who are actually out there still trying to stick to it. Nothing but props to you. Catch you in the next one.